Hi there, so I'm sure you've seen the videos of how the tubes were being made for this bicycle project, but now this is how the tubes are coming together to form the bicycle. Now, it might just look like a big mess on a table, which I'd admit it is a little bit, but I'll show you in more detail each single element and how it comes together to hold a certain aspect of the frame correct. In overview, the frame is lying on its side here, have the bottom bracket here, rear dropouts here, seat tube and seat post here, head tube here. So you can see this is the down tube, would sit somewhere in there, like that. Then the top tube would sit in like that. The bike is built to a center line. This table is being used to approximate flat. It's a piece of granite used for a countertop in a kitchen, so it's quite flat. Everything is built up a certain quantity to this imaginary center line that sits above the table. The center line chosen for this jig is 97.7 millimeters, which might sound strange, but the sizes always become strange when dealing with, for instance, 1/4 inch thickness in the rear dropouts. Means 6.35 millimeters thick. So two of those thicknesses gives the 0.7. That's the only reason why the 0.7 is there. So the BB shell is split in two at 97.7, splits the headset in half, splits the seat tube in half, and divides the rear dropouts. So they're all laterally spaced here. And the only thing that needs to be done with rulers and measuring and paper is they're spacing fore and aft. But you can quite confidently put the rear dropouts anywhere and they will be in the right position with regards to the left and right movement that they could have on the frame. Yeah, let's take a closer look at each of the components. This here is the bottom bracket support. See the bottom bracket sitting in here on this plate and this calibrated length of a standoff here. So if I unscrew this top, with the top unscrewed, a taper comes off. That taper centralizes the bottom bracket shell on the stand. Bottom bracket shell then comes off. This is simply the BB30 adapter that would be pressed into a BB30 frame if you wanted to run standard British threads. It is a 68mm bottom bracket, and that explains why this spacer needs to be used. This standoff was built to be used with a 70mm bottom bracket, just in case I wanted to use a 70mm one on a later bike, which I probably will want to. So this spacer has a 1mm lip. So the Italian bottom brackets are 70mm, this is 68, so you need 1mm each side. And that spacer just drops in and allows you to step it to the correct position. Then we simply just have the standoff, which is glued into this base. How it is glued is through a pin and a flat surface, so it is perfectly perpendicular. This thread is, or this section of threaded rod is simply a bicycle rear axle. I chose to use many bicycle axles in making the parts just because their threads are very accurate, and that I'm pretty confident that's sticking very vertically. Reassemble it now. And just snug tight like that, it's accurate. Here we have the rear dropouts, again mounted to a very similar base as the bottom bracket, and also using a bicycle axle for its accurate threads. The calibrated standoff is this small section at the bottom. The dropout is then sat on top, clamped with a nut, and then the top dropout is clamped with 2 nuts. The standoff is only meant to be used with 130mm spacing and 1/4 inch thickness dropouts. This here is the head tube mounted to its jig. This jig has to be calibrated. So once the head tube is mounted, a DTI gauge is used and run along the top first to get it level, and then it must just sit. A vernier height gauge is used to figure out its height off the table. That height off the table, again in the center line, has to be the 97.7. The DTI just checks that it's level and at the correct height. Then it's set up and it can be moved anywhere on the table and be at the right height. This jig also uses a bicycle section of threaded rod, and the head tube is simply clamped between two cones. So I'll undo this. Speedy motion. So here's the head tube itself, just a piece of aluminum. See the one cone that supports it, then a section of 1/2 inch aluminum, then the bicycle rear axle. This cone is threaded to 10x1, which is what the axle is. So you can quite simply just slide on and tighten. Ready to go. Now the seat tube is one of the more complicated things to hold. The only thing that really matters about the accuracy of the seat tube is how the seat post sits. So as the seat tube sits in the jig, the seat post is already installed. This second clamp behind here, I'm not sure if you can really see it, is the actual seat post clamp that will be used on the bicycle, and it's holding the tube onto the seat post. The seat post is held to the jig through this clamp, and then the jig adjusts in the exact same way that the head tube jig does, except now the seat post is measured for flatness and height off the deck. So apart from getting everything in plane using a jig, the rest of the positioning is done with a lot of calculation and a lot of measuring and protractors. These pieces of paper have lines drawn on them where the tubes are expected to be. Their lengths are measured and the angles that they are apart from each other are measured. And they are placed in the approximate position. I've been using this handy dandy frame and laying it over top just to make sure I'm not doing a calculation incorrectly. It also settles the mind when you get a length that requires a large portion of extra tube to be cut off, just to make sure you're not cutting that tube too short. Having a frame to sit over top is a nice comfort, I'll say. So that outlines the jig that was used to make the bicycle. As you can see, it's all packed up now. That's because the bike's actually finished. Kind of the magic of editing, that this was all filmed a very long time ago and I've just been very lazy. But tune in for the next video. I know this one has been pretty long, but there will be another one which will show the bike completed and hopefully it being taken for a spin. So I'll see you then.